Hello everyone. I welcome you all to the crash course of ECAL. I hope all are doing well. All right. So in today's class, we are going to start about physical properties of metals and non-metals. I'll be sharing the screen here with. You can see this screen here. Just give me a second. All right. So metals and non-metals. Children, these are basically the elements. Metals and non-metals are the elements, and they are a part of matter that we have around us, right? In class 9, you have studied that matter can be divided in two categories, pure substance or mixture. A pure substance is the one which is made up of identical atoms or identical particles. But mixture is made up of more than one type of particle. So in pure substance, we have two categories, elements and compounds. This also you have studied in class 9. Elements are the basic, simplest substances which cannot be broken down further. But compounds are made up of two or more elements that are chemically combined. Now elements have two categories further, metals and non-metals. So this classification was done on the basis of some properties, which you have already done, physical properties, in, I think, class 8. So it will be a recap of those activities one by one. You can see the picture and get to know or guess what property we are talking about. This is about the hardness. Metals are hard. Almost all metals are hard. The exception is there, sodium. You can see here, sodium and potassium are two metals which are not hard. Sodium is a soft metal which can be cut with a knife, and potassium also can be easily broken down. You can cut it into pieces very easily, right? So this is the first physical property, hardness. Now, the second property also you can guess when you see these pictures. All metals are lustrous. They have luster. They have shine in them. That is why metals are used in making several objects. Some examples are there in front of you. So the second property is being lustrous. Metals are all lustrous. Now, this picture can give you an idea. I'll stop sharing one so that this black box goes away. Right. So all metals are good conductors of electricity. You can see here, the metals are good conductors of electricity, and this is the reason that all the metallic wires have a cover of PVC, polyvinyl chloride, on it. This is insulator. Because the metals are good conductor, they have to be covered with a non-conducting material. So all metals are good conductors of electricity. The next property you can guess here, like we have a metallic rod here. These are the pins which are stick to the metallic rod with the help of wax. With the help of wax, all these pins are attached to this metallic rod. Now, if you keep a candle over here, what will happen to these pins? These pins will start falling one by one, starting from this, the first one. And gradually all of them will fall away. So this activity shows that metals are good conductor of heat as well. All metals are good conductor of heat. That's why the heat reached the rod got heated up and it conducted till the other end of the rod. So the pins are falling one by one. The fact is that silver and copper are the best conductors of heat. and even electricity. Lead and mercury are comparatively poor conductors of heat. They are not as good as silver and copper. So different metals have different conductivity. Conductors of heat and electricity metals are. The next property is about being sonorous. It means that they produce a ringing sound when you hit a metal. We know the most common example here is of a bell. The bell is made out of metal and it gives a ringing sound, whether it is manual bell or electric bell. So this is the next physical property of metals, that they all are sonorous. Now here also exceptions will be there for sodium and potassium, which are soft metals. They are not sonorous, right? The next picture can give you a hint when you see the metal sheets over here in this flower. The petals are made out of metal sheets. It shows that metals are malleable. Means you can convert them into sheets by hammering them repeatedly. This is called malleability. So all metals are malleable, but gold and silver are most malleable. The next picture shows you about the duct or the pipe-like structure which is made out of metal. So it shows that all metals are ductile. They have ductility. Means they can be drawn into wires. Again, all metals are ductile except, of course, sodium and potassium, which I mentioned before that they are soft metals, so they are not malleable nor ductile. Gold and silver are most malleable over here. Even most ductile. Gold is most ductile metal. So that was about malleability and ductility. The next property is they have very high melting point. The melting point and boiling point are extremely high for all the metals except gallium. Gallium is a metal which has the melting point of 35 degrees Celsius. 35 degrees Celsius is the melting point for gallium. So this is one exception. But otherwise all other metals are having high melting and boiling point. The next property is about the tensile strength. The diagram makes it clear what are we talking about. Tensile strength is the strength of the metal uh, with which it can resist the force as much as possible without breaking. Because the metals have high tensile strength, this property of metals is used in making suspension bridge. Suspension bridges are the one which do not have any pillars to support them from the bottom. They are just hanging at the banks. You can see these are two poles and they will be just hanging between the two poles. And these are very thick, strong metallic Let me share the screen again. Okay. So you can see the screen again. Here we were discussing about the physical properties of metals and non-metals. This is a white colored metal which is being cut with a knife, and it is sodium. This sodium metal is being cut with a knife. So it is this soft, and this is potassium metal over here. It can be broken into pellets with the help of hands only. So the next property here that we are discussing is about state of matter. All metals are solid in state. They may be soft in nature, but they are solid. Okay. So now, children, we start the physical properties of non-metals. Non-metals are not very hard. In fact, most of them are gases. So they are not hard. Even if they are solids, they are not hard. Like carbon. Coal is carbon. They are not. It is not hard. Next is lustrous. They don't have any shine except two non-metals, silicon and graphite. They shine. They have luster. So the next physical property is conduction of heat and electricity. Non-metals do not conduct heat or electricity except graphite. Graphite is the only non-metal which is a good conductor. So the way we have exceptions in metals, we have exceptions in non-metals also. Sonority. Non-metals are not sonorous because, as I told you, most of them are gases. So it's quite obvious they are not sonorous. Next is malleability and ductility. They don't have any such property. They are not malleable, not ductile. Their melting and boiling point is not high, the way we saw for metals. Graphite is an example where the melting point and boiling point is high, but otherwise for other non-metals, it is not high. Tensile strength is very low for non-metals. And state of matter, mostly, as I told you, they are gases. Bromine is a non-metal which is liquid. So here two examples you have to remember. You may be asked about a liquid metal and a liquid non-metal. Liquid metal is mercury, hydrogyrum, and liquid non-metal is bromine. It can be a 1 mark question or MCQ, something like that. They are extremely less in densities. They have low densities. So these are the 9 physical properties of metals and non-metals. So this were very easy to understand also because, as I told you, you have already studied them in your previous classes. Now there is a question based on these physical properties. The first one is you have to give an example of a metal which is liquid in state at room temperature, a metal which is liquid. So it is mercury. We have just now discussed it is mercury. The next question is a metal which you can cut with a knife easily. It is sodium. The next question is the metal which is the best conductor of heat. Which one? I am sure you must be recalling. It is silver. Silver is the best conductor. Then the metals which are poor conductor of heat, they are lead and mercury. So these are the questions based on the physical property of metals and non-metals. The next question is explain the meaning of malleability and ductility. Malleability is the property of metal by which it can be hammered into sheets. And ductility, this is malleability. Malleability. And ductility is they can be drawn into wires. So this is called ductility. Here you can have a definition or 1 mark question, MCQ, right? So these were the simple things. Next, you have a question. You have been given a hammer, a battery, bulb, wires, and switch. How could you use them to distinguish between the samples of metals and non-metals? So they are asking you, will you be able to distinguish using these substances? So the answer can be yes, it will be easy because hammer can help you decide whether the substance is sonorous or not. Battery, bulb, wire, and switch can help you decide whether they are conductors of electricity or not. If they are good conductor, it is a metal. If it is sonorous, it is a metal. Otherwise, it is not. Right? So this is the question here. Very simple kind of. So first part we have completed the physical properties of metals and non-metals. Now we will be discussing the chemical properties of metals and non-metals. So when I say chemical property, it means the the way they react, the metals and non-metals react with the other substances. So let us start it. I'll be sharing the screen over here. All right. All right. So the first property, as I told you, will be the reaction between metals and oxygen. When metals react with oxygen, they produce metal oxide. For example, sodium reacts with oxygen to give sodium oxide, right? And this is a violent reaction. What you have to do is you just expose sodium to atmosphere. It will react with the oxygen present in the atmosphere and it will start burning on its own. You just have to expose sodium to the environment and it starts burning. It is this violent. The reaction is very violent, right? The next one is sodium. The reaction between sodium and oxygen. It is also a vigorous reaction. It takes place very fast. Magnesium and oxygen will give you magnesium oxide. This takes place upon heating. Means you have to take a strip of magnesium and you have to heat it. Once you heat it, it will start reacting with oxygen to give magnesium oxide. So in these three examples, we have discussed about the reaction between metal and oxygen to give metal oxide. The thing that we saw here is, out of the three, all metals do not have the same intensity of reaction. Like sodium reacts violently, potassium reacts vigorously, and magnesium reacts upon heating. Now, when you put these oxides in water, say for example, if you put sodium oxide in water, you will get sodium hydroxide. Okay. And similarly, if you put potassium oxide in water, you will get potassium hydroxide. If you put magnesium oxide in water, you get magnesium hydroxide. And all three are bases. Potassium hydroxide, sodium hydroxide, magnesium hydroxide, they all are basic in nature. We have studied in the previous chapter. You will get to know that these are basic because litmus paper will turn from red to blue when you bring it in contact with these substances. So it makes it quite clear that they are basic in nature. So one conclusion we can come up here is metallic oxides are basic in nature. Metallic oxides are basic in nature, right? Now let us see a few more examples. You can see aluminium reacting with oxygen to give aluminium oxide. This reaction is upon burning. See, we started with a violent reaction, then vigorous, then upon heating. Now it says upon burning. Now, if we take this aluminium oxide and make it react with an acid, hydrochloric acid, we get salt and water, right? Now, we know the nature of HCl is acidic. So, a substance X reacts with an acid to give salt and water. This substance X is basic in nature. We have just now seen 1 minute back that all metallic oxides are basic in nature. So aluminium oxide reacts like a base. Now we see one more reaction involving aluminium oxide. This is aluminium oxide reacting with a base to give salt and water. NaAlO2 is a salt called sodium aluminate. This also we have discussed in the previous chapter, sodium aluminate. Now here in this equation, aluminium oxide is behaving like an acid because acid and base react to give salt and water. So in the second equation, it behaves like an acid. So this is strange. Aluminium oxide has basic as well as acidic nature. Such oxides are called amphoteric oxides. Amphoteric oxides are the metallic oxides which show both basic and acidic nature. So here in our conclusion, we can add this word also, that metallic oxides are basic or amphoteric in nature. Right? Now we'll see one more example. Zinc reacts with oxygen to give zinc oxide. Zinc oxide is also amphoteric in nature. It will have both acidic and basic property. So when you get a question like what are amphoteric oxides, they are the metallic oxides which have both the nature, acidic and basic, are called amphoteric oxide. Two examples are there, aluminium oxide and zinc oxide. These are the two examples. In this equation, we can see iron reacting with oxygen at a very high temperature and copper reacts with oxygen on prolonged heating. So remember, we started with a violent reaction, vigorous, upon heating, upon burning, at high temperature, prolonged heating. So this shows that the metals are arranged in decreasing order of reactivity. The first ones were highly reactive, and when we move down here, the reactivity decreases, right? It is this question that I was discussing with you. What are amphoteric oxides? Give two examples. So now you know the definition and examples also. In case they ask you to give equation, you can give these two equations. In this picture, you can see a piece of sodium was kept in conical flask and it was just exposed to the environment. It was just exposed. This is sodium. And it is in flames, you can see. It is in flames because it reacted with oxygen in the nature, in the atmosphere. So it is highly reactive. Now, this is the reason that we keep sodium under kerosene. Kerosene is a petroleum product. It's a kind of oil. And you can see these white colored pieces of sodium kept immersed in kerosene. Now, this kerosene will not allow oxygen to come in contact with sodium. So sodium is safe in storage. Right? Here in this picture, you can see magnesium ribbon being burnt. It burns with a very white, bright, dazzling flame. So this is again here 1 mark question, like what do you observe when you heat a magnesium ribbon? So you can say it catches fire and it burns with a white, bright flame. Why is sodium kept immersed in kerosene? We just now discussed, because it is extremely reactive. It reacts with the oxygen present in the atmosphere and it explodes or it catches fire, which can cause accidents. Okay. Now, the next one is non-metal and oxygen. The non-metals react with oxygen to give non-metallic oxides. We'll see some examples. The first one is carbon reacting with oxygen to give carbon dioxide. Second is sulfur reacting with oxygen to give sulfur dioxide. Now, both these oxides are acidic in nature. How do we prove it? We prove it by putting it in water. You can see the equation here. This carbon dioxide, when you put in water, it changes to H2CO3. This is the carbonic acid, and I'm sure you must be knowing what is carbonic acid. Carbonic acid is the one which is present in all the soft drinks or the cold drinks, whether it is Pepsi or Cola or Thumbs Up or whatever. They all have nothing but carbonic acid into it. Second is, if you put sulfur dioxide in water, you get H2SO3. This is sulfurous acid, sulfurous acid. So these two examples make it clear that non-metallic oxides are acidic in nature. They will also convert blue litmus red, so that this makes very sure that they are acidic in nature, right? Now we see one more example here. If carbon reacts with oxygen in less availability of oxygen, if the oxygen available is less, you will get CO. This gas is carbon monoxide. Mono stands for one. Because we have one oxygen here, it is carbon monoxide. In the previous slide, we saw CO2. It was carbon dioxide. Carbon dioxide. So, this carbon dioxide is produced when more amount of oxygen is available. So here we get to know that carbon can produce carbon monoxide or carbon dioxide depending on the availability of oxygen gas. Hydrogen is another non-metal. It reacts with oxygen to give H2O, which is water. Now children, water is not acidic nor basic. It is neutral, right? Similarly, if you put CO in water, you won't get anything acidic. This is also neutral. So in the previous slide, we saw two equations which were indicating that non-metallic oxides are acidic in nature. In this slide, we see they can be neutral also. So we can add this information to the definition that non-metallic oxides can be acidic or neutral. They can be acidic or neutral in nature, right? So this question, what type of oxide is formed when non-metals combine with oxygen? They can be acidic or neutral oxides. All right, now we go to the next question. Pratyush took sulfur powder on a spatula and heated it. He collected the gas evolved by inverting a test tube over it. The diagram makes it clear. You can see a spatula over here having sulfur powder and it is being heated. The gas fumes are being collected in the test tube. So this test tube contains the gas which is produced when sulfur reacts with oxygen. Yes, I'm sure you all must have guessed it correct. The gas produced is sulfur dioxide, right? And we 2 minutes back we saw it is acidic in nature because it is non-metallic oxide, sulfur dioxide. So the question is, what will be the action of gas on dry litmus paper and moist litmus paper? With dry litmus paper, no change. With dry litmus paper, no change. Because in the last chapter, we discussed that if a substance has to behave like an acid, it must produce H plus ions, which are produced in the presence of water. In the absence of water, they will not be produced. But if you have a moist litmus paper, the color will change from blue to red. So it indicates that the gas produced is acidic in nature. So these are the answers over here. The second part of the question is write a balanced chemical equation for each reaction. So the first reaction is sulfur reacting with oxygen to give sulfur dioxide. The second equation is sulfur dioxide reacting with water, which is there on the litmus paper to give H2SO3, sulfurous acid. So this question can be a 3-mark question. Okay. Now the next one is reaction of metal with water. Children, metals react with water to give metal hydroxide along with hydrogen gas. But if it is steam, if it is water at room temperature, we get metal hydroxide. But if it reacts with steam, we get metal oxide. So this you need to remember. The equation, if it is steam metal oxide, if it is water metal hydroxide, the other product is the same, hydrogen, in both the cases, right? So this example you can see here, potassium is reacting with liquid water, means at room temperature. So we got metal hydroxide along with hydrogen. And one thing, did you notice over here, a lot of heat production took place. So this is exothermic reaction. Exothermic reaction. Exothermic reaction means it gives out energy in form of heat. This is violent reaction with cold water. You don't need anything. You just put a piece of potassium in water and it will react violently. Another reaction over here is sodium reacting with water. You get sodium hydroxide, hydrogen gas, and heat. So in both the cases, heat is produced. Now, this heat comes in contact with the hydrogen gas. And we know that hydrogen gas is highly combustible. It is highly combustible. So hydrogen starts burning. So when you see this reaction happening, you will see that the piece of sodium or potassium which you have put in water has started burning. It is strange. It is strange. A piece of metal in water starts burning. Right? So this you have to remember, that these reactions are exothermic and they make the hydrogen catch fire. Right? You can see this picture, a piece of sodium is being cut and it is being put in water. So it has started burning, it is in flames. And sometimes the amount of heat produced can be so much that it can break the beaker. So you have to be very careful when you are doing this reaction. Now, some more examples are given here. Calcium with water will give you calcium hydroxide, hydrogen. Here also heat is produced. So this is also exothermic reaction. With cold water, it is less violent. It is not as violent as sodium and potassium reacting with water. Magnesium and water will give you magnesium hydroxide. This is possible in hot water. So as I told you in the last case, when we went down the series, the reactivity decreased. So here also the same thing is happening. It started with violent reaction with cold water, less violent with cold water. Now we need hot water. Here you can see magnesium is reacting with steam. So you get magnesium oxide. Remember I told you, these two you have to remember. Magnesium reacts with liquid water at room temperature or with steam. So here it is magnesium hydroxide. In the second case, you have magnesium oxide. Aluminium and water, it reacts with steam only to give aluminium oxide. Zinc reacts with steam only to give zinc oxide. Iron reacts with steam in red hot condition. It means here it is steam where it has got a lot of energy, and this also has to be extremely hot, then only you will get iron oxide. So basically the intensity of reaction is decreasing. The metals go on becoming less reactive. Now, what is the logic of this reaction? How come metals react with water? So we'll see this with the example of sodium. Two atoms of sodium are taken and they are reacting with two molecules of water. So let us see first. We already know that metals are electron donors. So when they donate electron, they become cation. You can see here Na plus. They have donated the electron, right? So they become a cation, and some similar thing happens with water also. Water splits in H plus and OH minus ions, right? Now, the Na plus over here reacts with OH minus. They combine to make NaOH. And this hydrogen ions take up the electron and convert to hydrogen gas. So the logic of this reaction is that because metals can donate electrons, they can react with water. So you can see the overall equation here. This is the overall equation given. So you have to remember the logic. Depending on that logic, non-metals with water. Any idea how do they, I mean, what do they produce when they react with water? Non-metals have a tendency to gain electrons. They have a tendency to gain electrons. So they do not react with water. They do not, there is no reaction between non-metals and water. If you put some sulfur powder in water, it won't react. It will simply sit in water. Right? Okay. Now we will see, like we have discussed two properties, the reaction of metals with oxygen and with water. In both of them, we saw that the intensity of reaction was decreasing, and based on that, we have the reactivity series. The reactivity series is a sequence of metals which are arranged in decreasing order of reactivity. You can see this. Potassium and sodium are on the top, which react violently with cold water. Calcium is next, which reacts slowly with cold water. You can see earlier it was violent reaction with cold water. Now it is a slow reaction with cold water. These four, magnesium, aluminium, zinc, and chromium, react very slowly with steam. Now it is no more cold water, it is steam. Still, the reaction is very slow, but they are quite reactive in an acid. Iron, nickel, tin, and lead are moderately reactive with high levels of acid. You can see, even if with high level of acid, they are moderately reactive. But copper, silver, platinum, and gold are not reactive at all in acid. So the reactivity is decreasing when we are moving down. The reactivity is decreasing. When we rise up, the reactivity increases, right? Why does this happen so? Why is it that some metals are more reactive and others are less reactive? It is all because of their nature to donate electrons. The metals, as I told you, are electron donors. They have a tendency to donate electron, to lose electron. So if they readily give away electron, they are very reactive. And if they do not easily give electron, they are less reactive. So basically, it is on how readily they lose electron, right? If they lose the electron easily, they are more reactive, else they are less reactive. So the ones which are on the top, sodium, potassium, calcium, they easily give their electrons. But the other metals like copper, gold, silver, platinum, they do not give their electrons that easily. Reactive. In fact, they are called noble metals because they don't react. Now, in this reactivity series, you can see hydrogen written over here. Hydrogen is a non-metal. Still, it is having some position in the reactivity series. The reason is, children, it can lose or gain electron. It can do both. It can lose or gain electron. So that's why we need to compare hydrogen with the other metals, right? The next property is the reaction of metal with acids. Remember in the second chapter we discussed that all acids contain hydrogen in them. So the metals which are more reactive than hydrogen, you can see a small reactivity series shown here. All these metals which are above hydrogen are more reactive than hydrogen. So they will all react with acid to produce hydrogen gas. And the ones which are below hydrogen do not react with acid at all. So metal and acid will give you metal, salt, and hydrogen. Some examples are there in front of you. Sodium reacting with hydrochloric acid to give sodium chloride and hydrogen. The reaction is violent. Again, magnesium does the same thing. It reacts with acid to give salt, magnesium chloride, and hydrogen. Aluminium produces aluminium chloride and hydrogen. This is a rapid reaction. Initially, when you put aluminium in acid, you will not see it reacting. It seems as if the piece of aluminium got sit in the acid. It is not reacting with it. But this happens because the layer of aluminium, there is a layer of aluminium oxide on aluminium, and it got produced because aluminium reacted with the oxygen when it was kept in storage. So this layer of aluminium oxide acts as a barrier. So the first thing happens when you put aluminium in acid is this layer dissolves. After this layer dissolves, the aluminium gets exposed and it starts reacting with the acids. Then you will see a vigorous reaction, a rapid reaction rather taking place. So this can be a 2-mark question. They can ask you like, why is it that initially no change is seen when you put aluminium in acid? So the answer, as I told you, because of the layer of aluminium oxide which acts as a barrier or protective layer. Aluminium will react with acid once this layer dissolves. Okay. Then zinc reacts with acid to give zinc chloride and hydrogen. Iron gives iron chloride. Copper does not react. You can see the reason here. Copper is less reactive than hydrogen. So it will not react. Right? Now, the question is, which gas is produced when dilute hydrochloric is added to reactive metal? It is hydrogen gas. Write the chemical reaction when iron reacts with dilute sulfuric acid. So you can write Fe plus H2SO4 gives FeSO4, ferrous sulfate and hydrogen gas. Right? Now, the next one is name 2 metals which will displace hydrogen from dilute acids and 2 which will not. So now we know the reactivity series. You can name any metal which was above hydrogen, any 2 out of it will react, and any 2 this below, any 2 below will not. Right? So you need to remember the reactivity series. So this is the answer over here. You can read it. Sodium and potassium will react. Copper, silver, platinum, gold will not. Okay. Now this is very interesting. Nitric acid will not give hydrogen gas when it reacts with metals. The reason is, children, nitric acid is a very strong oxidizing agent. So you know what happens? When you put a piece of metal in nitric acid, the hydrogen gas which is produced immediately gets oxidized to produce water. So we don't see hydrogen gas at all. The moment hydrogen gas is produced, it converts to water. So it says that we don't see hydrogen gas when a metal reacts with nitric acid. The answer is this only, it's a strong oxidizing agent. Right? So the water is produced when hydrogen gas is produced, it immediately converts to water. But there are 2 metals, magnesium and manganese, which react with very dilute nitric acid. Now, very dilute nitric acid is not a very good oxidizing agent. It will not oxidize hydrogen gas to water. So very dilute nitric acid will give this reaction. It will show hydrogen gas bubbles in acid, with magnesium and manganese, right? Now, aqua regia is a very interesting mixture. It is a mixture of two strong acids. The acids are nitric acid and hydrochloric acid. The formula for nitric acid is HNO3, and the formula for HCl, hydrochloric acid is HCl. So you take one part of HNO3 and three parts of HCl. You get the mixture that is called aqua regia. Now we'll go in more detail about this aqua regia in the next class.